Hello everyone, this is Steve. Thanks for joining me. We're going to draw this hyperbola here and then just tell a bunch of things about the graph. So let's just go ahead and get started. So this hyperbola, just like all of our hyperbolas in Math 121, is centered at the origin. So we're going to start by drawing our reference rectangle. So we've got a 9 underneath the x squared and a 16 under the y squared. We also notice that the x squared is first. It's the positive term and the y squared is second. It has the negative in front of it. So this hyperbola is going to open like this. But regardless of which way it opens, it is the number under the x squared that gives you the secret to moving left and right, and the number under y squared that gives you the secret to moving up and down. So the square root of 9 is 3, square root of 16 is 4, so we're going to go ahead and move up and down 4, and left and right 3. Cool. Now I'll draw in my dashed rectangle here. And my asymptotes, which must go through the center, which in this case is the origin, and right through the corners of the rectangle. Where are the vertices? Well, they're on the middles of the sides of the rectangles for the direction the hyperbola opens. So my vertices are right here and here. So my vertices for this particular hyperbola are going to be plus or minus 3, 0, like that. The vertices are also the endpoints of what we call the transverse axis. So for this one, the transverse axis is going to be 6 units long. And the other way across the box is called the conjugate axis. So the conjugate axis for this one is going to be 8 units long. So there's no rule about which is longer, the transverse axis or the conjugate axis. In fact, they can even be the same length. Okay, I will now sketch in my hyperbola, being careful not to enter the box, except just touch at the vertices, and not touch the asymptotes. So there's half the hyperbola. There's the other half right there. Remember, a hyperbola is a completely different shape than a parabola. It is not just two parabolas, it's a hyperbola. All right, once we get those in there, we can say a few more things. I can give my domain. Now this one, my domain has a break in it. So the domain is going to go from negative infinity all the way up to negative 3, including negative 3, but then jump from 3 to infinity. But it does go up and down forever without a break, so the range is going to be negative infinity to infinity. The asymptotes, well, here's the secret to the asymptotes, everyone. The asymptotes for a hyperbola that is centered at the origin be y equals plus or minus some slope times x. How do you find that slope? Start at the center, in this case the origin, go up and over. We go up 4 over 3, up 4 over 3. So our asymptotes have slopes of 4/3 and negative 4/3. And that takes care of the asymptotes. What about the foci? Where are they? Well, the foci are in the same direction as the transverse axis, the same direction as the vertices, but they are beyond the box. We find the foci, I think I can squeeze that right in here, by adding the numbers together under x squared and y squared. So 9 plus 16 is 25. Taking its square root is 5. And that tells us that we go left and right 5 units. So the foci are actually going to be plus or minus 5, 0. So right there and right there. Okay, I think that should be everything. Hope that helped. Thanks for watching.